Yeah, it said there was no input.
It says 120 hertz.
Oh, time to get on to the Zoom.
Oh, the screen came up and said that?
Yeah.
That, yeah.
Yeah, we said that before. The bridge sits here.
Oh, yeah, that's right.
Oh, fuck, it does.
I appreciated yesterday's guest speaker so much, especially when I was able to like be vulnerable and honest about my code and like, oh, you're okay, you're learning, just stick with what you like doing and you'll get there. It was a nice little head of my there.
Sometimes you just gotta jiggle the cables.
Yeah, sometimes.
Oh, there's Brady.
But that's not my level of troubleshooting.
I got my new iPad.
You are always getting some sort of
He likes his toys, doesn't
It's like
he?
you're like a magnet
Yeah.
for like electronic devices.
I have like multiple devices that I get for the same price. I can just get like one.
What is my video?
So like my phone and this iPad together.
You can go to your Zoom settings and change it.
I thought I did that yesterday. It did that to me.
Oh, sometimes it changes it back for you, I think.
Very, very polite of it.
Yep. I know my face will start showing up after I've been successfully shut off for a while.
Very nice.
We still got a couple minutes. Yeah, if people show up.
I wonder where Ethan is.
He's usually a little slow. I usually give him about 10 minutes after class. So it's got. I have one of the kids.
Would you either of you guys have Raspberries? I want to play with one so bad.
I have a Raspberry B or whatever it was. Well, it used to be the new one, but the new one back. I don't remember what it's called.
Aren't they pretty expensive though? That's the only thing keeping me from getting one.
Yeah.
No, I feel like
Oh, what the heck?
Yeah.
But I don't know what's keeping me from getting one.
So,
I guess I assumed they'd be like hundreds of dollars.
they're just expensive.
Oh, really?
They're arms, but they don't have any royalties. It depends on the model. I think there's a $100 model. I think the higher it goes.
You could like connect these things to like robots.
Yeah.
Cool stuff. Yeah, that's what I want to do.
It has, I think the newest one has like full HDMI.
No, I want to build a little room so bad.
I want to put like lights that are adjustable in my car, so I can turn on the turn signal, light just like. Yeah.
Do you think people use Raspberry Pis to do those cool like shows on their house? I always wondered, or is it just like a light timer?
Well, I imagine most people aren't savvy enough to use a Raspberry.
Gonna relax.
Yeah.
Yeah, but they're cool if you're into like shows where like they have like mouths and stuff.
Yeah. Oh, maybe. They probably make a device that does that. Yeah.
I didn't even think of that. Light show device.
So it's just like each plug-in like turns off and on, like the different lights. Right. I know there's one that like
What would you
glows.
do, timed light show? I'm trying to think of how to word that. What Google gave me.
I know.
Timed light.
Still missing a P.
No.
Try
Let's see what that is.
light.
Okay, guys, as we get started, can you see in Discord this syllabus addendum that I posted last night? The general 101 chat of our server that still needs an icon, and nobody has submitted an icon design for. Pitiful thing. I'm gonna grab this.
So I went through sound icons at one point, and I don't remember why I didn't post it.
Me too.
I probably wouldn't let you. You'll have to try and find it again.
I think you're right, and I think it was like one of those where I was like, nope, I've done too much today, I'm done.
Ethan had set these servers up for me that first one, and it's awesome, but
There we go.
it apparently locked people out of a whole lot of stuff.
Yeah, a lot of them will not let you
So
say.
just let me know, because I'm just opening stuff up like crazy. I want to use it. I don't want it to be here. Okay, so these are my
That was 93 though.
updates to the syllabus, because we have had some positive cases in our room, not while you guys are here, not in this class at all. People that have been notified, or that I've been notified about that were positive, had not been in the room for a couple of weeks because they had been working remotely. So we've not had that. But so far, I've been really encouraging everybody to be here in person. I'm kind of going to back off of that and let you decide if you would like to be here in person or if you would like to be here on the Zoom session. Now, realize we've had some people that have been forced to be stuck with the Zoom session for a little while for other reasons, and they can tell you it's not necessarily the same as being in class. There's going to be things that are missing. I'm going to leave you out, but it is an option. So if it's something that is just, you know, like I had one student who was in the class who did receive the email from the OTC people about being in the room, sent an email, and he was just like, I just can't come, I just can't come. Okay, well, I respect that. You know, so if he wants to work remotely from Zoom, that's fine. Because it was really critical for me to be able to look at attendance and know where that person had been, and the staff to know what people needed in email and what didn't. That attendance was really, really important. And I've been saying every day, you guys help me with this, help me make sure that we've got it right. And it really struck home to me how important it was that we were doing that, because I could say, no, this person had worked remotely, so everything should be okay. Now, in order to make that process happen, I need people to be specific with their Zoom name when they connect to the session. Use only your full name. If we have people in both places, we can't find each other with a username, an OTC username, or some sort of other abbreviation. That class that I'm referring to has 3 people with the initials JW. And when I look at the Zoom, all 3 of them like to just use their initials and some stuff. And so I can't tell anything. So your name, after that, -remote, if you were not here. And then that way, people that are in your study group can look at the Zoom session and say, oh, they're here, they're just not in class. And so they can try to include you in these group activities. Now, if you make that decision where you're forced to stay at home, it's going to be your responsibility to really be pushing to be included in those group activities. You're going to have to make sure that you're sending them messages, that you're using the Discord server, letting me know if it doesn't work, if something's not letting you use it, so that you can use it. So I think this way we can tell where everybody is. RJ, I noticed yesterday, which is great, he was connected to the Zoom session twice, so he could put, you know, RJ-laptop, his RJ or whatever, but I think our location there. For right now, I just want to leave that empty if we're in class, but we might get to a point where we decide we'd like to put it no matter where we are. So we'll wait and see how that goes. So just want to let everybody else know where you are, because some people are probably going to choose to work from home. Be prompt. I have to admit everybody manually into our Zoom session. So I'm just going to come out and say, if you're not trying to get in the Zoom session within the first few minutes, you might be left out. If you get left out, the video of the class will be posted eventually to YouTube. You might have to wait for that turnaround to happen, but try to be on time. I know at home especially, it can be, I would be sitting there like 10 minutes before something was going to start, and then I'd get distracted and not be there when it was going to start. So that can happen. So remember, we have that video. So that's our worst case. But we need everybody to be here because you guys are seeing already how much you benefit from each other's input when you're working on these activities, on these models and these different things. Data modeling is just not a solitary endeavor. It can be, and we can do all sorts of research on our own, but we'll do a lot better if we have other input, things from other people. Let's look at some. Any questions about that? Anybody have any suggestions, any other ideas of something that we should do? You've probably seen suggestions that other instructors have come up with where I haven't, because I'm always stuck in here. So let me know if you've got a better idea. This is a model, right? So this model, someone, Legos. Someone did, right? They put this model together. They did pretty good. They followed the instructions, right? Yeah. You did. Have you ever known people that couldn't put Lego models together? There's a lot of them. The instructions can be kind of tough. So this Lego model, I think it achieved its objective. They decided what they were going to do with their Legos, and they came up with a model, and they set about construction, and they did it all good. I don't know about this one.
Anti-Lego shoes.
So this was definitely a plan. There was obviously a plan involved, and maybe some sort of, I don't know, diagramming.
Can't step on Lego. I'm already walking on.
Yeah, you don't have to worry about it. It's Lego safe shoes, Lego safe slippers. But yeah, you know, there's maybe a little bit, you know, more modeling that can be done there. This model, have you ever seen any like this after Christmas? I've seen some. I've seen a lot where people just gave up. Do what? I still have giant crates of Legos that I can never get rid of because my former children have said they have to stay there forever. So anyways, this is what some people's would look like. My sister's kids, you know, they just hated stuff like that. They never did it. This looks like what the kids left behind at the house. This is the kind of model, this is the kind of data that you guys might encounter when you get out to work and you are trying to understand what somebody before you has done, and this might be what it kind of looks like.
At the same time, I kind of want to run my fingers there, like, you know, those rocks that you see, like, I just kind of want to grab a handful of it.
Yeah, exactly. Take care of it, take it home, and then this is what can happen if your modeling effort is just a big giant fail. Actually, it said that this is how he was sleeping, and it's just a meme. So she says he might be immortal, but I think the Lego model got him. So as we look through the presentation, last time, not yesterday, we had some of our models. If I can go backwards. I'm on the wrong screen, so it's not listening to me. Some of our models for our class kind of followed the plan. I'm just going to close this because it's not listening to me. Technical difficulties, sorry. Some of our models followed the plan, and some of them sort of looked like that big giant wreck we saw, right? Or the slippers. So we want to make sure that as we're making our data model, we're being as thorough as we can be and as accurate as we can be, because we usually want the model to come out looking like the picture in the instructions, at least somewhat if we're following instructions. But we don't want it to be just a big giant hot mess of Legos that everybody wants to grab. So I want you to think about how your team did last time and what kind of things you could have strived to achieve. Were you focused on things that maybe distracted you from getting the entities all put into place? Was there a lot of just different instructions? Was it just a lot of effort? There was a lot of stuff. Some of them just looked awesome. But I wanted you to think about that if you are creating a data model, we want to make sure that we get all of the entities in place first. And then we start looking at how the entities are related to each other. And then we start adding all of the attributes to all of our data entities. And that's kind of where we are with this advanced data modeling. We need to add our attributes. We know already that we've put in like primary key fields and maybe secondary key fields to establish some of our relationships. But I've just kind of been ignoring all of the other attributes that go along with our entity. And that's just been me. That's because we're going to have some sort of tool to use as a database administrator or a database designer or a data modeler to keep track of all of this stuff for us. These tools are called case tools. Do a quick Google search on that and let's see what we could find. So CASE, in this case, stands for Computer Aided Software Engineering. And these are just tools like Visio that do the same thing as Visio or maybe take it even a little further for you to use to keep track of all of the elements that you've encountered in your design process and all of the entities. And so different tools will keep track of things in different ways. And you probably notice the book referring to these, and it'll say this model, you know, is used in this tool, and they're referring to these different case tools. So some of the inconsistencies that we've seen in those different diagrams relate directly back to these different tools. One tool might show, you know, the entity relationship diagram using these kind of symbols, and another tool might show things just a little bit different. So I know it's been a little bit of a frustration looking at our textbooks sometimes is what exactly do they want? And I've been like, it'll be fine, because what exactly is going to be wanted is going to kind of depend on what case tool you use. And as long as you understand that you're trying to document entities, relationships, you follow some guidelines about how all of that's done, you're going to be able to communicate this information to other people, and that's what we're looking for with our data model. So now we're going to get a little more specific and look at those entities. So I'm going to go find that PowerPoint, see if I've got everybody here right. I think I do. I don't think we have anybody at home. Still no Ethan. Greg's here though. Okay, few changes. Is that it? I think that's it. We have got it. So I'm going to go find that presentation for this section and get it pulled into my OneNote. And while I do that, so I'm looking at Canvas, it reminds me about something important, that next Thursday we're going to have guest speakers via Zoom. And so I've posted a discussion board assignment for you to post a question for them. And we have a few people in class that were here yesterday for our guest speakers that were in the C#2 class, and they can tell you how important it is to come up with a really good question, because this is your opportunity kind of as an open forum to get some experts to answer these questions for you. The people that we'll have here, well, via Zoom next week, Jason Dean graduated from OTC a couple years ago. I'll let him tell you exactly when. He was employed at a company in Springfield that shut down, and through some retraining efforts, him and several other people came to OTC and went through the CIS program and were successfully retrained, yay. And he's going to have either another person that went through that with him that also works at the same place, or his boss. The boss was kind of interested in taking over because I think he wants to get a word into all of you all about coming to work for him. We'll see how that goes. So they said, well, we're not super database administration people, but we do SQL all the time and we create databases and stuff. So I think they'll be pretty good for us. So you don't have a lot of turnaround on that question. Since they're going to be here next week, I'm asking for you to get it done before the weekend, and that way I can get the questions to them so they can come up with hopefully a plan for how they want to answer everything for you guys.
Is there such a thing as a bad question in this case?
Right. Well, I've seen students ask bad questions. Yeah, I have. Some like, how much do you make? That's a bad question. We can't say things like that. We can say, is your lifestyle improved?
That's what I mean, like,
Did you? I didn't think that you.
Okay, so I got my one note. I'm gonna drag this PowerPoint into it maybe.
That's what I thought.
right.
This chapter gets down into the real nuts and bolts of looking at our attributes. We've been talking about, which ones are primary keys and things like that. But sometimes we need to go through a process and kind of examine things a little bit more in detail. There are a lot of terms in this chapter that are kind of new to me. So as we go through it, you can laugh and make some notes about those terms, as I do too. So I'll get a lot more familiar with them as you do also. So some of these models are things that you might not see as often as other things. So the first one is this EERD. The extra E just stands for enhanced. So when we go from an entity relationship diagram to an enhanced entity relationship model or diagram, we're just adding a little bit more detail.
So it says extended in the title and then it says enhanced. Is that on purpose?
No, could this be why some of these terms are getting me? Is that why I wanted to bring up the book? Because I kept thinking,
Well, I know, and that
Look
was
at that.
a legitimate question. I didn't know if maybe the authors meant that. Like,
Well, it says extended in every place except this one, doesn't it?
yeah,
We got extended, extended, extended. Let's vote for extended. But I see an issue also. Thank you. So hopefully there won't be a test question where they give you both of those as a possible answer. There could be though.
Then you cry.
You're like, I don't know which one.
I was going to say that's very much an appropriate response to that.
That's when you go in after the test and you're like, both these answers are acceptable.
Yeah, and I have to just update everything again.
That sounds fun.
It is super fun. So as we go through and we're looking at all of our attributes, we're going to start noticing some things that are different data types, different types. So when I look out at you guys right now, just looking at students, I can see a lot of different types of students, right? I could say, well, I have, first of all, students that are different sexes. I have students that are different ages. If I look in the room, I have a career center student, have a veteran student, a couple of them, some other people. All of these students could be considered different subtypes of students, right? So as we're going through and we're looking at all of this information, we have to decide, are these subtypes like important enough to almost comprise additional entities? Or are they just pieces of information that we can carry on the main entity as attributes, like, military service Boolean or something like that? So we have to go through some further analysis here, now looking at those different data types. So what we end up with are supertypes and subtypes. If we start carrying all of these different pieces of information on our main entity, we can end up with a bunch of columns that come up with null values because they're not relative to this entity instance. So for example, in this one, looking at Jean here, She doesn't have any licenses. She's never been rated. She doesn't have this medical type field at all. All of these null values, because all of these different pieces of data don't apply to that person, to that employee. So should we be carrying all that null nothingness? It's not taking up any space, but it is causing overhead in us. And we have to be aware of our data so much to know whether those things are expected to be null or not. So we can end up with some nulls because of that, or just things that don't make any sense. So let's look at their definition here. An entity supertype is a generic entity type that is related to one or more entity subtypes. So if we look at students and veteran students, which one would be the supertype? Students. And which one would be the subtype? Veteran students. What about career center students? Another subtype, right? So the student itself is our supertype, and we're analyzing as we go through this process, this modeling process. Do these other subtypes deserve their own entity to go along one-to-one kind of relationship with that student, that supertype entity?
The supertype would just be the main thing that all the subtypes go under. Like if you're doing like different models of like a car, then all the models would be subtypes.
Right.
Would be the supertype.
Exactly, and I think they have a picture here. Here we go. In this case, they have a picture of an employee. And here's what they've added to our model. They've added in this kind of category symbol is what they're calling it. And they're saying that this model now shows the different subtypes of employees in this example. So here we have an employee. We can have like pilot, mechanic, and accountant subtype employees. So in this case, they are looking at this, deciding if these are worthy of becoming their own entities or not. So we haven't decided that. Even though looking at this model, it looks like we have these different entities. We might decide that we have to collapse those back into our supertype depending as we go. Now, notice that this is called a specialization hierarchy, because down here they talk about how we can even have other types of models that get into this specialization area. And the case tools, again, are going to help us do all of this analysis. They're going to make us go through all of the different data elements that we've identified and make sure that we know how they're used. Now, I want to kind of veer off for a second here and look at that. As we've gone through our data analysis, realize that on the side, we should have been creating a list of every attribute that we're encountering, right? So if we are coming up with an employee, this last name, F name, initial, all of these different data elements should be off in a list somewhere, right? Every single data element we have. And in this case, they've decided anytime we have a last name data item, we'll prefix it with something about our table name, and then we'll call that data element L name. And we want to be really consistent like that because we want to be able to identify every instance of a certain data element. We could have employee named something else in a list somewhere, like employee number, and we could miss the fact that that's included off in another entity that we need to analyze. Another entity could be another subtype. So the specialization hierarchy just shows us for this specific employee entity that there can be some specialization based on this employee type. So looking at that, looking at those different subtypes, we're going to be examining all the different unique attributes each of the subtypes have to decide, do they need to be their own entity? Does that make sense?
Yeah.
They have our relationship types for is a. So whenever we're working with a subtype like this, we can say a pilot is a or an employee, a mechanic is an employee, an accountant is an employee. So that type of relationship keys to us that we're looking at specialization of a supertype.
This sounds very object-oriented.
Uh-huh. Sounds just like a class,
Sounds like we're
doesn't
just
it?
using different words.
Yep. Pretty much, pretty much. That's exactly right. So it's almost that same decision we make in any area of software development. Where do I break off another class? Should this be its own class or should this be part of this class? That's really what we're looking at the table. Look at our employee pilot here. For that previous example, they said that one type of employee was a pilot. So here's just kind of a spreadsheet view or a tabular view of the different data elements. If we're looking at the employee table, we're going to see these data elements. If we're looking at the pilot table, we're going to see these other data elements. And again, we're looking at this supertype, subtype relationship to determine how much data should be contained in that subtype versus in the supertype. Now, here's when it's a little bit more messy. Here we have a person. Depending on the type of person we have, they could be an employee or a student. If they're an employee, they could be an administrator or a professor. If they're a student, they could be a graduate or an undergrad. Could they be an employee and a student? I could hear, right? Could they be a graduate and undergrad? No. So we have different types of supertypes and subtypes. So let's look and find where they're defining how they want these letters. I gotta find it. So if you look at that first figure, 5.2, a specialization hierarchy, right here where they're pointing to the letter D, they say that within that circle, we're identifying whether this is a disjoint or overlapping constraint. Looking at this relationship, they say it's disjoint. That means I'm either a pilot or a mechanic or an accountant. I can't be more than one. If we have overlap, then we could be more than one, like our employee student. So within that circle, we should just see a D or an O. So D, disjoint, you can only be one. The O would be overlapping, that an employee could have multiple instances of a type. Now, the other things that they've got there on that circle is the subtype discriminator. Sometimes I wish that I could just invent new terms.
Right.
But the subtype discriminator is simply the name of the column we're looking at. So we're saying, based on the employee type, these are the subtypes we have.
So I think you just mentioned it, I'm not in this. The category symbol, is there something other than a circle?
They're including this line underneath it and this subtype discriminator, this column name. So the category symbol to me is just this circle, but that whole set is involved. And
Would they have like other symbols like square or? Okay, that's all. I was just trying to figure out because I highlighted that one.
I think that's it, just the circle and the line underneath it. Now the line underneath it says that it's a partial or a complete constraint. So I see our overlapping subtypes. But I'm not seeing the partial or complete. Constraint, we will find it. Now, whenever we're looking at these sub-entities like this, we would always be using the same primary key. So we would always expect a one-to-one relationship, right? We're either going to have one of these entities exist or not. So that kind of relationship would be implied. Now I want to get a little bit more clarification on the lines here, what exactly they mean in this diagram. But we've got two lines under the O indicating overlap, that a person can be both an employee and a student. And then we've got the two lines here indicating that same level of overlap. P is employee, P is a student, student type. I'm not seeing it. We'll find it. So that should be our disjoint and overlap. Already talked about that. Here it is. The completeness constraint specifies whether the supertype occurrence must have at least one of the subtypes. So if we are saying that, for example, that person Jean that was in our very first example that had a bunch of null values, that person did not have any association with any of those subtypes. So they're calling them partial completeness. Total completeness means that every supertype occurrence must have at least one of the subtypes. So I'm just going to put that up. Once you get it in your notes or get it highlighted. So our completeness constraint, partial completeness, we don't have to have a subentity in total completeness. We do. Here's their pictures.
Okay, can you enlarge 5.2 real quick so I can get a snip of it?
This one?
Mm-hmm.
Yeah.
Thank you.
Well, that didn't help much.
That's okay, then I'll just-
I'm not sure which view is better. I'm going back to this
I'll
one.
yeah, I'll
You
do
just
it
get the
there.
paper strip here.
Got it.
Yeah, sometimes it makes you mad how you like click for a larger image and it's just like.
Usually they're pretty good at it. That's the first one I've seen like that. I bet you guys run into it all the time. Okay, so our symbol is really not just the circle. Our symbol is kind of everything here. And so we're going to have the O or D inside of it. And then we're going to have one underline if we don't really care about having a subtype. We're going to have two underlines if we must have one of the subtypes in existence. So yes, this is a great one to get a sniff of. Perfect. So when we're looking at all of this data, it can be kind of hard to analyze everything. So there's a couple of different approaches we can use. Top-down approach is called specialization. This is where I'm looking from above and I'm thinking, well, I need employees and I see I've got this employee type data attribute. I wonder what it is. How many types of employees are there? What can I do with those employees? What are the special characteristics of them? So that specialization approach is working my way down through the attributes. Generalization is kind of the other approach, saying, well, I have students that are veterans that have special requirements or special situations. Are there other types of students that I might need to investigate that would be the same way? And that's where we notice that something is a little different than others, and we work our way up from that bottom, saying, okay, what all is involved in that? Either way, we're identifying the differences in the different types. Sometimes it's easier for us to start at the top looking down. Sometimes it's obvious, noticing from the different instances. So, entity clustering. Take a look. You guys saw from that last case study last time that you could have hundreds of entity types. It was almost kind of overwhelming, wasn't it? Did a really good job at zeroing down in on what was important. But when we have so much, we're going to focus in on specific areas, right? And then we're going to kind of move around those different entities and make sure that we've got everything modeled for that given entity. As we move around, we're going to be working with really different entity clusters, right? Because we've got this one section over here that's kind of a chunk of things, and another section over here that's a chunk of things. Those clusters are kind of logical. It's not really an entity, it's just sort of a virtual relationship that we've noticed in our mind. So here's an entity cluster example from our tiny college. We have our whole entity relationship diagram here, but maybe we want to focus on this location and offering. How do we make sure that there's a place to have each class? Do we have all the data attributes in place to make sure that we can schedule all of our offerings? So if we really just focus in on that area, that would be an entity cluster for us. They're related to each other. They're dependent upon each other. I like this too. This is kind of the way I view it. When using an entity cluster, the key attributes of the combined entities aren't really shown here, no longer available. So we could think about just combining those together. And that's what we're kind of doing, is going through that analysis to decide. They say the general rule is just to avoid the display of attributes when entity clusters are being emphasized, so that we're not getting off looking at keys and things like that. We've seen as we've gone through our modeling approach that we are kind of always looking at different keys. How could we wait this long to decide what the primary key is going to be for each of our entities? Well, we know that we're going to have one, right? But we could be thinking about it for a while, but now we're to the point where we really want to make sure that we have the appropriate primary keys. You guys have seen that some of us just we have maybe a natural key. One is a social security number. Let's take a quick break here and Google this. If I can type, I'm going to just search for social security number. And I want to go to this www.ssa.gov site. I thought I saved this site that I wanted to go to. But I've got COVID brain. So I'll just go to this SSN numbering scheme. Sorry about that. I'll re-Google. I'm going to give you a second or two to just kind of read through that site a little bit about how that's formatted. So the number really is a composite, right? We kind of think of it as just being one number, but it's a composite. So from the very beginning of time, a database design, it should really not be a primary key, right? Because it's already a composite data field. So we could use it that way, but I want you guys to remember that anytime you're in a situation where you're maintaining social security number information, you just added to the security requirements of your organization overwhelmingly, because now you are responsible for making sure that data remains private and is secured. So although it's the obvious natural key to use for a person, especially at least in our country, it is not something that we should use. So it's something that has been used. We want to get away from it, make sure that we are not doing that. So sometimes this natural key, this natural identifier, might not be the right thing for us to use. I said it too. It also wouldn't be the right thing for us to use because it wouldn't be something that applied necessarily to someone that wasn't from the United States. And we don't know, like today, our company might only be in the United States. Tomorrow, they might buy out somebody that's in some other country, and all of a sudden we have to maintain all of this information that's international. So we should use some sort of key that we generate that's a unique ID, right? Now, in the state of Missouri, they decided that the state would generate unique IDs for all students so that individual colleges and schools didn't have to do that, and so that that ID could hopefully follow students from one place to another. So sometimes we have keys that have become natural keys that started out kind of as generated. So, but we want to think about that. Are there natural keys for this entity? Here are some guidelines, and these are really important. Not too much missing. First of all, of course, we have to be looking at a data field that's going to be unique across all instances of our entity. Never a duplicate. Never, never, never. It should be non-intelligent. We just saw the social security number is somewhat intelligent, so again, it doesn't fit the requirements. Non-intelligent. I don't want people making decisions off of this. It should not change over time. So your student ID should stay your student ID. It's preferable that it be just a single attribute. Again, not something that's made up of sub-elements. This is a big one, numeric. Why would we want our primary keys to be numeric? They say, the main reason is I can get an exact match. If I'm looking for employee number 1, I can find employee number 1. If I'm looking for Joseph E. Smith, then that key could be duplicated, of course, but it's also a lot harder to do those kind of comparisons with strings, right? We see that in C# programming. If we're going to do string comparison, we have to do some other work and do some extra things. So it's just easier for the database management system if all of our keys are numeric integers. We're never going to use, of course, a floating point field at all. It'll all just be integers. We want it to be security compliant. No security risks, like social security number. Have I harped at that enough? So the preferably numeric thing, I think, is the only thing that they haven't brought up a little bit before. But we want to use those integer data fields so that we can get an exact match and we can find things right away within our database. We've seen already that sometimes we have to use a primary key that's a composite. And here we just have confirmation that when we're working with those many-to-many relationships and we build this composite table or link table to connect the two, we're going to use both of the key fields that we've joined as a composite key. So that's an accepted practice. Another place might be in a weak entity. For example, we have an order system. So we have our customer and our order entity. And then for an individual order, we have line items. So we might just give those some sort of sequence number like 1, 2, 3, 4. And we would make that order number and line item number be our key for that line item table. That weak entity then is allowed to have that composite key because that's an important point to keep them unique. And then a surrogate key. A surrogate key is a primary key that's created by the database designer. So here we have an events table. This is the actual data that we need to keep track of. The date of the event, when it starts and ends, what room it's going to be in, what its name is. We're making money off of people's events, and how big the party is going to be. So if we look at this table and we try to find uniqueness, how could we get a unique key? Well, we would have to take the date and the start time and the end time and the room and the event name and how many were in the party to guarantee uniqueness, wouldn't we? Because none of the data in here couldn't be repeated. So there's no rules or anything in place to make us not be able to have a duplicate row. So what we could do is we could have all sorts of different ways of looking at it. We might decide, oh, we're going to combine the date and the start and all of these different things. But we know the best thing for us to do is to come up with an event ID that we generate, and every time a new event is stored, we add to that event ID, so we have a unique ID. So that's a surrogate key, and that's one that is generated by the database management system automatically every time we add an entry to our table. Now, they point out that we need a lot of practice in design, and you guys have done it. You've been getting it. Here's some for us. We don't want to go too much longer. We'll let you guys work on that case study with your study group. But let's take a look at this first one. Here we have a case where we're looking at implementing one-to-one relationships. They say foreign keys work with primary keys to properly implement relationships in the relational model. The basic rule is very simple. Put the primary key of the one side, the parent entity, onto the many side, the dependent entity, is a foreign key. Now this is a really important point because this is the only area where people are still showing confusion when they make their data models as to where that foreign key belongs. So if I'm looking at a parent, its primary key belongs in the child as a foreign key. So for example, here we have a relationship between employee and department. One employee is the manager of one department, and one department is managed by one employee. In that case, there are really two options for selecting and placing the primary key. We could have a foreign key in both entities, right? Let's see if they have a picture. There they do. So here we have our employee and our department, and we are saying that we could put the department code on the employee table, and if there was a department or manages department is a new attribute, and that would be a foreign key to the department table, which department this employee manages. Or we could add a managed by field to the department table that would point to which employee manages the department. In this kind of relationship, it could be hard for us to make that decision. So we're going to look at these rules for deciding where to put this foreign key. We could have a situation where one side is mandatory and the other side, let's say, is not. We'll make things up there and add additional words to that sentence. In that case, we place the primary key of the entity on the mandatory side in the entity on the optional side. So what are they saying there? When we're looking at an employee in a department, is there one that would be mandatory and the other optional?
Well,
Can we run our business not knowing what employee runs our department?
no.
Not really. Second case, both sides are optional. In this case, we would select the foreign key that causes the fewest nulls or place the foreign key in the entity in which the relationship role is played. Well, if we decided that was our case here, where either one was optional, and they say you want to place the foreign key in the one that would result with the fewest nulls, then we would have fewer departments. So that would be where we would place it. And then third, both sides are mandatory. They say, see case 2, or consider revising your model to ensure that the two entities do not belong together in a single entity. So maybe we should have some sort of department manager table. Let's look at this next one. In this case, we have some time variant data where the salary changes, we hope. But we want to keep historical information about what the salary used to be. So we're going to have an employee table, but then we're also going to have a salary history table that shows the date that salary started and the amount. Now, as we look at this, to create a unique key, we would use the employee number and the salary start date. Or we might want some other data item. And some other historical information there for you to read about. There's a couple more cases for you to look at before you work on all of the activities for this chapter, but I think you could go ahead and start with your case study with your group. So we were going to do, which one? Complete case number 4 with your study group. So we should be able to use the tools that you guys used last time to share everything. And we didn't turn anything in last time, but some people exported it as a PDF to show and other people did. So with that, is it lucid charts? Is that the one? I couldn't remember. I was like, I think that's it. I was starting to question myself. But we could save in a lot of different formats. For the cases, it's probably going to take a PDF. And then you guys should each be able to upload it. So it's fine if it'll be the same for everybody in your group. But just that one case study. Now the critical thinking exercises, there's only 2. They're pretty quick ones. They're kind of matching, fill in the blanks. So it's a lot less than what has been. Thank goodness. So, and then I need you guys to help decide, like in the future for all of the ER diagrams that you've done such a good job. We know that this lucid chart would work better for those, I think. Do you think that it would be easier as a student to put them all in one chart? And then just have one that you turned in instead of all those little piecemeal files, or would that be more confusing?
I
It
kind of like
depends on
turning
how
them in
much-
individually.
Did you?
Yeah.
Okay.
I may have put them all in one PowerPoint and just sent in the same PowerPoint.
Because that's what I would have done, but that's what I was wondering how everybody thought about.
I guess it depends on how many we were assigned, like when we got assigned like the 23.
That was a lot.
That would have been a little easier because I could have kept going, but when it's only like 5, I don't mind
That's not.
doing.
And with
it.
Lucid Chart, I think it's a lot easier to just copy and paste, so hopefully they would go faster. We'll see if it keeps working. All right.
So do case 4, is that what you said?
Uh-huh. Just case number 4. Okay, and we don't have anybody in our Zoom session today, I don't think. That isn't here, I mean. I'm gonna stop our Zoom session now.
The reason I'm getting up in your business is so I can